Hey folks, now let's get started with functional groups with double bonds. So as you can see, we have our ketones here and we have our aldehydes. The functional group portion here actually have the double bond within it, and that's how I'm distinguishing them. So it's the functional group portion I'm talking about when I'm saying double or single bond to organ. Now as you can see, both of them have the same type of group, which is going to be considered a carbonyl group. Okay, and this carbonyl group is carbon double bonded to oxygen, and both ketones and aldehydes have a carbonyl group. The only difference is what's attached to the carbon in the carbonyl group. So with ketones, we'll see that the carbonyl carbon is attached to other R groups. Okay, and then with aldehyde, we'll see that carbon is double bonded to oxygen with the carbonyl, and that's going to be bonded to hydrogen and one single R group. So let's get into that next. Okay, folks, welcome to the aldehydes, or the carbonyl chiefs. So again, we know they include that carbonyl group. Okay, they're ruled by the aldehyde kingpin, which is all about their boldness, their sharp and distinctive smells, and of course, all the aromas that come from them. And so they definitely give off these spells and definitely give off this kind of vibe in the mafia world. Okay, now there's a lot of functions for aldehydes. Like I said, it gives a lot of fragrance. So think of cinnamon, that's actually an aldehyde. Think of like almonds, say almond scents. That's also an aldehyde or flavoring as well. The most basic aldehyde we have is formaldehyde, which we know is a carcinogen. So it's carbon double bond to oxygen, and it's flushed with hydrogen. Okay, so we've seen formaldehyde. Now, what makes them so distinct? Well, first and foremost, they contain a carbonyl group, which is carbon double bonded to oxygen. Now, when that carbon or that carbonyl group is double bonded to a hydrogen and another R group, that is considered an aldehyde. So when you're looking for and trying to name the aldehydes, you're always trying to look for that carbonyl group first, and then you're trying to consolidate. Is this carbonyl group attached to a hydrogen and another R group, which could be another carbon and hydrogen, etc., or is it connected to two R groups? When it is connected to that hydrogen, it is going to be an aldehyde. All right, folks? So when we're naming aldehydes, we think of everything like we would with hydrocarbons. So the same kind of rules apply. We're going to have our prefix, our root, and our suffix. The only difference is that our suffix is going to replace the E that's at the end of a hydrocarbon with the ending "al." Not "ol" like in our alcohols. We're talking "al" as in "al." Okay? So for example, 2 carbon here, but there's a carbonyl group. That's going to be ethanol. So the F part comes from 2 carbons. Anol is going to come from the fact that we replace the E with the Al. Then we have propanol, 2-methyl-butanol, etc., etc. Same thing happens whenever you have that carbonyl group. It is actually going to be a part of the parent chain. So it probably will be a part of the counting. So you just want to make sure that that carbonyl group gets the lowest substituent number possible. Okay, let's get into some examples. So like everything else, we're going to have that prefix, our root, and our suffix, and we know the suffix is going to end with "al." All right. So again, you always want to think of the hydrocarbons when you're naming and layering information on. So when you're looking at these 2 structures here, the goal is that you want to always find that carbonyl group first. So we'll find that group, find that carbonyl group. So I have the carbonyl group here, and I have the carbonyl group here. And I want to show you this because it's written differently. Sometimes we see the Lewis structures, which is partially condensed, and sometimes we see it this way where it's like it doesn't show the double bond. Remember, CHO means that you have a carbon double bond to oxygen and attached to a hydrogen here. Okay? And of course, you definitely want to just remember that everything here is basically a flashcard moment. So stop yourself and make sure you're writing on the front of the flashcard aldehyde. On the back, we'll write a couple of examples, and of course, the nomenclature rules that you can. Okay? Now let's continue on. We found our carbonyl group. Great. We know that the ending is going to be "al." Now we have to figure out what the longest carbon chain is. Go ahead and get me another color. So we're starting off where the actual carbonyl group is. 1, 2, 3, 4, 5, 6. 6 is going to give us hex for the root. Suffix is going to be "al." Now, since this is all single bonds, that means technically I have hexane. I'm going to get rid of the E, and the ending will be hexanol. Okay? Now, do I have to put a position for my carbonyl group? Well, since it's actually numbered and being a part of the carbon chain, no, you don't. So that's just going to have hexanol here. Okay? The name for this structure is just simply going to be hexanol. Let's move on to the next. Now we know we have an aldehyde group here because we just said we have the carbonyl group that's attached to hydrogen and oxygen only. Okay? So it has to have a carbon hydrogen and a carbon R group bond on the carbonyl group in order for it to be an aldehyde. So we see that here. Now let's go ahead and count to get our longest parent chain. So we have 1, 2, 3, or we have 1, 2, 3. Either way it goes, this is going to be our carbon number 1. So that's actually pretty good. We have 1, 2, 3. That's going to be our little parent chain here, for example. So 3 is going to be propane. Why am I saying ane? Because this is all single bond. I'm going to get rid of the E and I'm going to get pro for now. Okay? Now, we do have a substituent here, so we have to consolidate that as far as our prefixes go. So again, we're going to say, okay, we have a substituent, which is going to be a methyl group. Now, what carbon is it on? Carbon 2. Boom. So the actual name for this will be 2-methylpropanone. Okay, on to the ketones, the carbonyl captains. And again, both aldehydes and ketones have that carbonyl group, so you have to make sure you're consolidating structure at that point. Now, carbonyls are going to be under the watchful eye of the ketone Kaiser, and this family holds a delicate balance between stability and reactivity, okay? Ketones function in many ways. Of course, the most simple would be nail polish remover, mop repellents, flavorings, solvents, adhesives, you name it, ketones can be a part of it, okay? Now, what makes ketones so distinctive? Well, they have to contain that carbonyl group, and that carbonyl group has to be attached to our group. So before with aldehyde, we had the carbonyl group and then we had a hydrogen here. But now with ketone, we have a carbonyl group attached to our groups, okay? Now again, you want to make sure that with ketones, it's actually very similar to what we have for aldehydes. You want to make sure that you are having a new ending. So we have our prefix, our root, and our suffix. We do have a new ending. You're going from E to -one, O-N-E, not one, -one, okay? You got to make sure you always have the carbonyl group with those R groups. That's something you have to verify. And we're still doing the lowest substituent in the chain, okay? So when we're looking at here, we have bute. So we have to have 1, 2, 3, 4 carbons. That's going to give us butanone, okay? Butanone, because we got rid of that E and replaced it with -one. Then we have a substituent left over, so we have to consolidate that. So we'll get to some examples of naming next. All right, let's get started. We have a prefix, we have a root, we have a suffix. You know, our suffix is going to end in -one, okay? We also know we have to have a carbonyl group with 2 R groups attached. So we need to make sure that we are identifying that carbonyl group, very similar to the aldehyde, okay? So I have my carbonyl group here, I have my carbonyl group here. Now, I have to make sure that I have R groups attached. There is no hydrogen attached here. There is no hydrogen attached here. They're both carbons. So I do have my R groups here, and I have my R group here. Okay, so I can officially say this is a ketone. Over here I have R groups. Over here I have R groups. Again, this is officially a ketone. Okay, folks? And so now we can get on to name. First, we get our longest parent chain. Again, our carbonyl group is going to be a part of the counting. So we want to get the one closest to the carbonyl group. You don't want to say carbon 1, 2, 3, 4. Because now the carbonyl group is going to be on carbon 3. We want carbon 1, 2, 3, 4 that way. Okay? So 4 is going to give butane, because it's all single bonds. It's an alkane at that point. Get rid of the E. We get butanone. Boom. Now after that, we don't have any substituents, so we definitely want to call out the carbonyl group here. We can actually say 2-butanone. Now, sometimes you'll have answers that just says like they want the location of it. Sometimes you won't. As you get higher in organic chemistry, of course, you'll see more detail from that. I will be accepting both answers just because it can get confusing. So just keep that in mind with this. So I will put 2-butanone or butanone. The one I would rather accept is 2-butanone. Okay. Now let's get to this one. We do have our R groups. So we want to find the longest parent chain. So we've got 1, 2, 3, 4 carbons. That could be our parent chain, or we can have 1, 2, 3, 4 carbons this way. So let's go ahead and do that. This is our parent chain here. We still are going to have 4 carbons, so that's butanone. Okay. And where is the carbonyl group going to be? That's going to be on the second carbon. So let's go ahead and name it. Write it 1, 2, 3, 4. Not name it, number it. So it is going to be on the second carbon here. So what I would recommend for the ketones, just to add another layer of distinguishment, is that you do add the location to it. Okay. So I will put, you want to have a location here. Go back. Now that means I'm going to put where the actual carbonyl group is. So it's 2-butanone. Now I do have a substituent here, and that is a methyl group. That's on carbon 3. So it'll be 3-methyl-2-butanone. Okay, folks. So again, With the ketones, I do want to add that layer of location.